Hey guys, today we're going to be talking about end behavior. So you learned this in Algebra 2, but you learned just up, up, down, 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 up, and up, down. We're going to make it a little bit more mathy. So first of all, following along with me on your yellow sheet, end behavior. The end behavior of a function describes how the function behaves at either ends of the graph or what happens to the value of f of x, or remember the y values, as x increases or decreases without bound. You can use this concept of a limit to describe the end behavior. So we've got left end behavior, which says as x approaches negative infinity. So the limit as x approaches negative infinity of f of x equals what? So essentially what this is saying is as the x values are going closer and closer to negative infinity, what is happening to the y values? One thing to take note of is when we write the limit as x approaches negative infinity or positive infinity, notice that the x approaches negative infinity is directly under the limit, and then f of x is written separately. That's really important for notation. If you write it incorrectly, you will lose points. So then we have right-handed behavior as x approaches positive infinity, and that's just positive now, of f of x. What values do we have? And then f of x values, so your y values, could approach negative infinity, positive infinity, or a specific value. So here's an example. Normally you wouldn't have all these words. You would just be given either the equation or the graph. But we're going to give you both just for this example. So given this graph of x cubed plus 2, what you would do is you're going to make a table. So here is the table that you would make. What you're going to do is you would start with x. You would write all of these values, negative 1,000, negative 100, negative 10, 0, 10, 100, and 1,000. Because the idea is we are wondering what is happening at the ends of the graphs. So if we talk about the ends of the graphs, then we care as the x values are approaching infinity. We want them to get bigger and bigger and bigger. And similarly, what is happening to our x values as they go to the left, getting smaller and smaller and smaller, going towards negative infinity. And I would like you to do these arrows. So since we care about the ends of the graphs, we don't want our x values to be like 0, 1, 2, 3, 4, 5, because that's just a small set. We want to get bigger and bigger and bigger. So hopefully that makes sense. To get these y values, you literally just substitute it into the equation. So pretend we already did that. Well, the graph already did. Anyways, you substitute in 0, you get 2. You substitute in 10, you get 1,002. You get the gist. So the next thing that I want you guys to do is draw out what is happening. So as you see, we go from 2 to 1,002, etc., and we're just getting bigger and bigger and bigger. So what is happening to our y values? Well, if they're getting bigger and bigger and bigger, then they're approaching infinity. As we go to the left towards negative infinity, our y values are also going towards negative infinity. Which, if we look at this graph, it's pretty obvious, right? If we look here, as our x values are getting bigger, our y values are also getting bigger, which makes perfect sense. So now you made your table, you've come up with your y values. Now it's time to make a conclusion. So your conclusion looks like this. The limit as x is approaching negative infinity of f of x, and remember this is saying that as our x values are getting smaller and smaller and smaller, what is happening to our y values? And as we can confirm with both the graph and our table, they are approaching negative infinity. Then we make another statement for our positive x values. The limit as x approaches positive infinity of f of x is equal to, well, what's happening to our y values? They're getting larger and larger and larger, so they're approaching infinity, and that's it. So you got two examples I want you to do now. This is just it. And like I said earlier, normally you're not going to be given both. You're going to have one or the other. But the first thing you're going to do, and I'll set you guys up, is make a table. So we have our x and our y values. And remember, you're going to start with, you're going to have 0. Because this is end behavior, we want it to get larger and smaller. So we're going to do 10, 100, and 1000. And then -10, -100, -1000. And then, to get my y values, I am literally substituting each of these into my equation. And don't forget your arrows. So just for reference, this is as x is approaching infinity, and this is as x is approaching -infinity. Now you'll find one of these examples is approaching a number. If you're never sure, couple of things. One, this is why we're doing 10, 100, 1000, because our y values will give us blatantly like what is happening. Are they getting significantly larger, or are they getting really close to one specific number? And if you can never tell, you can always extend your graph or table, and have even bigger. So instead of 1000, go up to 5000, or even go to 10,000, and you should still see the same pattern.